F equals to this summation sign that you see over here. This basically tells you that all these numbers, these are basically minterms. So if you look at the range, it goes from 0 all the way to 15. So it looks like it's a 4-bit logic circuit. And therefore, you know that for a 4-bit circuit, the range will be to the power 4. That means range will be anywhere between 0 to 15, right? To the power 4 is 16, and the range will be from 0 to 15 because these are 16 combinations, correct? Now for these combinations that you see over here in the parentheses, the output logic is 1, right? And like I mentioned here, where summation sign denotes the sum of minterms. And what are those minterms? In the previous video I told you, minterms are those for which the output function f is going to produce an output which is going to be equivalent to 1, right? Minterms 1. And here again, to the power n equals to 16, where n is equals to 4, and say those inputs are, I just label them as A, B, C, and D. Here is a Karnaugh map. So the best way to get an expression, what we have to find out here, the minimum SOP form, the minimized expression, Karnaugh map is one of the classic technique to minimize an expression, also known as K-map. Karnaugh map here, also known as, it's I believe Morris Karnaugh was his full name. It's named after him. Now I don't want to go into too much of detail because you might be wondering like how the combination takes place. What we are basically, K-map implies a gray code in which only one bit changes at one time, and hence the combination over here is going to look something like this, right? So what these numbers here such as 0, 1, 3, 2, 4, 5, 7, 6, 1, 2, and well, these are basically the 4-bit combination. What 0 means is 4 bits are A, B, C, D. 0, 0, 0, 0 makes a code of 0, right? Similarly, 0, 0, 0, 1 makes a code of 1. If you look at 2 over here, the 2 code is 0010, right? 4-bit code for 2 is 0010, which means A and B are 00, C is 1, D is 0. A is 0, B is 0, C is 1, D is 0, correct? Similarly, that's how the combination is going to look like. The sequence is going to be in a 4x4 K-map. And the reason it's a 4x4 K-map is because we got n equals to 4, correct? So starting off from the expression here, let's put the minterms over here. We have 0 is going to be 1, right? Because we have a summation sign, that means a minterm. Minterm is always 1. If this was max term, then it's instead of saying 1, it will be 0, right? And max term is we use this pi looking sign for that. Now, then we have 1, so we have 1 here. Then we have 2. 2 is going to be 1. 4, 5, 6, 7, 8, 10, 15. 8 is 1. 15 is 1. So I have filled rest of the minterms over here in the table. We are going to pair them up. And we always look for the largest possible rectangle possible in the size of 2 to the power n, right? So we can make a pair where we could have 1 just lonely, or 2 or 4 or 8 or 16, okay, and so on. What I'm trying to say over here is if you look at this right here, the adjacent one, the ones which are right next to each other, they can be paired up. 0, 1, 4, 5, they are right next to each other, correct? So they can be paired up. Similarly, this can also be paired up. The one on the outer edges, you can wrap them around like this. You can wrap them around like this, correct? And all the minterms need to be covered in pair at least once. Similarly, I can go with this as well. 7 and 15. Now, if you look at all the minterms, they have been covered with this rectangle once, at least once. There's one exception here. This one is covered by 2 rectangles, the one in orange and also with the one in the blue. And remember, the one on the outer edges, they will be basically make a chord. Okay, they are making a chord. It's a group of 4 bits. Now we are going to drive an expression. So f here is just simply going to be, we're going to look at this right here first. 7 and 15. What is, well, the common between these two terms, because these two terms overlap with 7 and 15? Well, the common here is b, and similarly on the x-axis here, the common is cd. So this becomes cd. The expression is going to be cd for this pair. Now we're going to look at this blue one, right? Again, we look at these two terms because these two terms overlap with this rectangle. Common here is a bar, and similarly we look at the common between these two terms. You got c bar, d bar, c bar, d. The common between them is c bar, right? So you get c bar here. Then you move on to the last chord, which is basically the one in orange, the edges at the top and at the bottom, right? What is the common between these two terms? Well, you get a bar, b bar here, and you got a, b bar. So the common here on vertical axis is b bar. Let's look at the common on the horizontal axis. On the horizontal axis, what is the common here? Well, you get c bar, d bar here, and you get c, d bar. So the common is d bar. So you get d bar. All the expressions have been obtained for the 3 set of rectangles or pair, whatever you want to call it, we had. And this is the simplified expression, which cannot be further simplified. So f, output function f equals to bcd plus a bar c bar plus b bar d bar.